Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about the law of cosines. In our last video, we talked about how we can use the law of sines to solve oblique triangles. But there will be certain types of oblique triangles that you need more than the law of sines, because we don't have sufficient information. If we tried the law of sines here, we don't have the side opposite the angle we're given, and we don't have the angles opposite the other sides that we're given. So we're going to have two unknowns in this, which we won't be able to solve. Similarly, if we had this oblique triangle where we're given the three sides, we don't have any angles, so again we would have two unknowns. So therefore, we're going to talk about the law of cosines and how we can use that to solve these two oblique triangles. So if we have an oblique triangle in general, the law of cosines is this. The side c squared will equal a squared plus b squared minus 2 times a times b times the cos of c. Now, you might not always have your sides labeled a, b, and c in that same way, but we can move this around so that a squared would equal c squared plus b squared minus 2bc times the cos of a, angle A. Or we could also write it as b squared is equal to a squared plus c squared minus 2ac times the cos of angle B. So those all three are the law of cosines, and you can use whichever one depending on how you label your sides and your angles. Let's take a look at how this works. In our first example, we have an oblique triangle where we know two sides and the angle between them. We've already determined that the law of sines is not going to be able to be used yet because we don't have enough information. So therefore we're going to use the law of cosines, and I'm just going to label arbitrarily the sides and the angles. So if this is angle A, this will be side A. So the side opposite that angle will be the lower case of that angle. If this is angle B, then this will be side B. And if this is angle C, then this will be side C. Okay, so you just have to make sure that your sides are opposite the angle. So side C is opposite angle C. And I'm going to, because I know the angle B, I'm going to use b squared equals a squared plus c squared minus 2ac times the cos of angle B. So I'm going to use the particular form of my law of cosines that fits for the information I have and how I've labeled the sides and angles. Now I'm going to plug everything in, and what I'm going to be able to find is length B. So A is 15, C is 10, and B angle is 110 degrees. We can multiply there and get 300 times the cos of 110. I'm just going to do all of this on my calculator, and I will get 427.6. Therefore, take the square root, and B will equal 20.7. Now that I have length B, I now can go to my law of sines. So if this is 20.7, I'm going to use the law of sines to find either angle C or angle A. It doesn't matter which one. So I'm going to find angle C first. I plug in my values. B is 20.7. Angle B is 110 degrees. C is 10. and I want to find that angle. Therefore, I'm going to cross multiply. So 20.7 times the sine of C will equal 10 times the sine of 110 degrees. Divide by 20.7. I get a value of 0.454. I take the inverse sine of that value and I get an angle of 27 degrees. The only thing missing is angle A. I could repeat this to find angle A, but a much easier way to find angle A is to use the two angles that I have, and A will equal 180 degrees minus the sum of those two angles. So 180 degrees minus 137 degrees, which gives me 43 degrees. So now I've solved this oblique triangle. Let's take a look at another example. In this next example, we have an oblique triangle that has three sides and we don't have any angles. So our law of sines is not going to work initially. I don't have enough information. So what I'm going to do is use my law of cosines. And before I do that, I'm just going to label my angles and my sides. So if this is angle B, and this is angle C, and this is angle A, then this will be side C, this will be side A, and this will be side B. When I use my law of cosines in this example, I could choose to solve for any of the angles. I'm going to choose to find angle C. C squared will equal A squared plus B squared minus 2AB times the cos of angle C. So I plug in the values I know. 200 squared will equal 100 squared plus 125 squared minus 2 times 100 times 125 times, in this case, I don't know the angle. So I'm just going to try to simplify as much as I can. So I'm going to get 40,000 will equal 10,000 plus 15,625 minus 25,000 times cos of angle C. Let's move up here. I'm just going to combine those. So I'll have 40,000 will equal 25,625 minus 25,000 times the cos of C. I'm going to subtract 25,625 from both sides, and I'll get 14,375. And what I want to do is I want to isolate cos of C. So I'm going to divide both sides by negative 25,000. Find that ratio, negative 0.575. Find the angle, I obtain a value of 125.1 degrees. So a little bit of work. Be careful with your algebra in solving this. You can't subtract these because this is 25,000 times something. So you have to isolate that term first and then isolate that factor. Now that we have an angle, we can use our law of sines to find another angle. I can use my law of sines either with the side A and angle A, or B and angle B. It doesn't matter which one. We plug in our values, so we know C is 200, side C. Angle C is 125.1 degrees. B we know is 125, so we want to find angle B. we're going to cross multiply. Isolate sine B by dividing both sides by 200. And then I get, sorry, I'm running out of room there, a value of 0.511. So I find B by taking the inverse sine of that value. And we get an angle of 30.8 degrees. Last step, I know angle B, I know angle C, I just need to find angle A. In order to find angle A, I know the sum of all my angles is 180 degrees. So A will equal 180 degrees minus the sum of B and C. So that's going to be 155.9 degrees. And when I subtract that, I get 24.1 degrees. I've now solved this oblique triangle. So you'll notice when you're solving these oblique triangles, you're going to have to figure out which law will work best initially, but you're going to possibly use a combination of laws. It just depends on the information that's given. So practice using both law of sines and law of cosines, and we're going to move on to other topics in trigonometry. Take care and see you on the next video.